All right, I'm back. I'm still on page 235. This is the work that I've done so far. We're actually going to return to part B when we get to part D and part E. So this part's particularly important, but we're going to do the next part. So let's see. It says, suppose you take R and rotate it around the x-axis. Describe a three-dimensional solid. This formed as completely as possible. Find its volume, including units. So hopefully you can see your picture of this. And what I'm going to do is I'm going to start off with the 3D thing. So what happens is you're going to get faster. Like that last one took us a really long time, but it took a really long time because we don't exactly know what we're doing. It's like doesn't have a way to do parallel lines. I wish it did. I wish a lot of things about this. Let's see. Here we go. All right. So we're going to take this. This is our region. So if you remember, this is 4. This is 10. I mean, it's entirely possible that you're watching this immediately after the last one. So obviously you'd remember. I don't know. We're going around the x-axis. So this is x. This is y. This is z. So it's going to be the same idea. You want to focus in on like what happens when you hit that other coordinate plane that's involved, because that's like the key to doing these. So we're going around the x-axis. So I'm going to start in the xy plane. I'm going to rotate, and eventually I get to the xz plane. When I get to the xz plane, the shape is still a rectangle. The y value will be, not the y value, the z value will be 4 because as you rotate, you're just going to go like this, and you'll hit there. And so from there, what we can do is go this way, and then maybe go, oh boy, never been more obvious that I missed it. Let me do this. Oh boy, can I even fix this? I don't know. Let me try. I'll get one more shot. I'm gonna go up first. So vertical, and then I'm gonna go across. That was way better, I think. Okay, so that's what we get when we hit the XZ plane. And so I'm gonna try to fill this in like that. So that's 1/4 of the figure. I never draw the entire figure. I struggle to draw this part of the figure. So now what I'm gonna do, think about, so which plane is giving us our like cross sections, right? And in this case, since we went up, we hit the z-axis, it's the YZ plane that we want to focus on. So I'm going to focus on the YZ plane. So this will be, this is Y, this is Z. You can see I'm going to hit a circle. You actually, in some plane, you will always get a circle when you do this, because we're always going around. Well, yeah, I mean, you're just always going to get a circle in some plane. So this, maybe, that's probably really bothering some people, like that. Okay, so this is 4, and this is 4. I feel like this picture is really crucial. So here, we can definitely write an equation for this. This is y squared plus z squared equals 16. We can definitely parameterize that, right? Y is 4 cosine, z is 4 sine. That'll work. What's happening with x? Well, x can be anything between 0 and 10. So x can be anything between 0 and 10. Let me jot that down. Zero to 10. So now you're maybe going to start getting a sense that there are some patterns here. So the thing that we're rotating it around is going to be like a different parameter. The one that gives you a circle is going to be a different parameter, usually t, because I do cosine t, sine t. So that's going to give you a circle. And then the other thing will just be like v, and v goes from like where can you start to where can you stop. So to write parametrics for this thing, so this is for the surface, it's not a curve anymore. It's going to be x equals, y equals, z equals. Okay, so I'm going to deal with the circle first. So y I'm going to say is 4 cosine of t. And then I don't know when this stray mark showed up. Z is going to be 4 sine of t. And then I'm going to say, so 0 t. If you play around with GeoGebra, it's harder to forget this part because when you use the surface command, you have to like tell it what can t be, what can, I'm gonna use v for my other thing, what can v be? So v, and v can be anything between 0 and 10 because x goes from 0 to 10. That's where I got 0 to 10. So these are my parametric equations for the surface, which is pretty cool. So I'm gonna, what am I gonna do? I'm gonna box that in like some color. So these are parametric equations for the surface. We should probably also just describe it in words. So, I mean, if you look at it, you're gonna get a cylinder where the radius is 4 and the height is 10. And so the volume is going to be r squared is 16, 160 pi, and then it's volume, so units cubed. Okay, so we're going to get faster as we do these. I'm going to stop this one here and come back and obviously just keep doing more. All right, so I hope you are still finding these helpful.